It began with a sound so faint it barely rose above the noise, a soft, rhythmic pulse buried in the static of the universe. It lasted only a few seconds, the kind of fleeting anomaly astronomers delete from their screens without a second thought. But this time, no one pressed delete. Because even in those first few moments, there was something different about it. Something structured, something deliberate. At 3:17 UTC, a signal arrived from deep space. A signal with no clear origin, no obvious source, and no natural explanation. It came from a region we've never visited, never observed up close, and certainly never expected to hear from. And as the data scrolled across the monitors, the scientists who first saw it all felt the same thing. A quiet, electric shiver running through the room. They knew instantly, this could change everything. The story really began earlier that day, thousands of miles from any city, at one of the Square Kilometre Array stations in Western Australia. A place so open and silent that you can hear your own heartbeat in the desert air. The SKA is designed to listen to the universe with unparalleled precision, gathering whispers from billions of light years away. But that morning, it heard something far closer. A narrow-band signal, unnaturally clean, razor-sharp, and repeating at regular intervals. 16 hours precisely. It didn't drift. It didn't distort. It simply echoed, again and again, across the cosmic background. Within hours, data from partner arrays across the world confirmed the same thing. SETI verified it. NASA double-checked it. ESA cross-referenced it. This wasn't noise. This wasn't interference. This wasn't accidental. It was intentional. And as news leaked into forums, private Discord channels, and late-night posts on Reddit, the public felt the tension rising long before any space agency went on record. Before scientists ever consider the extraordinary, they must eliminate the ordinary. Earth is loud. Radio towers, satellites, radar systems, even kitchen appliances can mimic signals that look cosmic. There's a famous case where a microwave oven created data that fooled astronomers for years. So they checked everything. Was it a satellite reflection? Was it military radar? Was it the telescope itself oscillating? One by one, every possibility fell away. The signal held steady through all filters. The direction didn't shift. It didn't line up with any known human-made transmission. Its source lay far beyond our own star, in the direction of Proxima Centauri, the closest stellar neighbor to the Sun. 4.24 light-years, which meant that whatever sent this signal, sent it years ago, and only now was it reaching us. Humans have always strained to hear something, anything from the cosmos. The WOW signal in 1977 appeared once and never again, like a cosmic prank with perfect timing. Fast radio bursts, or FRBs, still mystify astronomers. They're brief, unimaginably bright, and come from galaxies far beyond our own. And for a time, even the strange dimming of Tabby's star sparked theories of colossal alien structures before science suggested more grounded explanations. But this new signal didn't behave like any of those. It wasn't chaotic or inconsistent or fleeting. It didn't drift across frequencies. It didn't vanish into silence after one lucky detection. It repeated methodically, predictably, almost patiently. And intentionality is the one thing the universe does not create by accident. When researchers decoded the first layer of the signal, the mood shifted instantly. Beneath the carrier wave, embedded in the timing of the pulses, was a numerical sequence not random, not approximate, but exact. Prime numbers: 2, 3, 5, 7, 11, 13. A universal language. The simplest way to say, we are intelligent, we understand. Nature can be strange, even deceptive, but it does not generate prime sequences by chance. Not like this. Not perfectly spaced. Not on a single narrow frequency. The room grew quieter as the implications spread through the teams analyzing the data. If someone out there was trying to communicate, why now? And why us? When the triangulation analysis came back, it pointed to a narrow region between two objects in the Proxima Centauri system, close to the orbit of Proxima b, a rocky exoplanet that has long fueled speculation about habitability. Proxima b sits in the star's habitable zone, that fragile region where temperatures could allow liquid water to exist. But the red dwarf it orbits is violent, unleashing solar flares that might strip away any atmosphere a young world tries to hold on to. Still, the possibility of life has never been fully dismissed. And now, a signal focused, patterned, and unmistakably engineered appeared to come from that very neighborhood. But the most unsettling part came next. The signal changed, as if responding to the attention, as if aware. Over the next several weeks, as teams fed the data into supercomputers, new layers in the signal emerged. Patterns within patterns, like knots in the fabric of a message waiting to be untangled. The structure resolved into a geometric sequence, the kind that appears in molecular chemistry and the stable arrangements of certain crystals. It was repeated with mathematical precision and encoded in binary, the same form humans used in the 1974 Arecibo message. But it was the coordinates that truly shook the scientists. Coordinates expressed not in kilometers or degrees, but in the hydrogen line frequency, the radio signature of the most common element in the universe. The same universal constant we used to communicate our own message to the stars half a century ago. It was as though someone had taken our method and sent it back to us, a mirror held up across the void. The scientific community fractured in an instant. Behind closed doors, tensions rose. Some argued this had to be a natural phenomenon we hadn't yet recognized, an exotic astrophysical process, perhaps linked to Proxima's solar flares. Others insisted that the statistical odds were too impossible to ignore. And then came the question no one wanted to say out loud, but everyone was thinking. Should we respond? To answer was to reveal our presence, our precise location with a level of clarity no previous broadcasts had been achieved. To remain silent was to risk losing what might be the only conversation humanity has ever been invited into. During one late-night debate, a researcher finally said what everyone feared. The question isn't whether we're alone. The question is whether we should say hello. Eventually, after weeks of discussion and classified meetings, a plan was drafted. The response would be simply the smallest possible acknowledgement. One word in binary, received. No detailed information, no coordinates, nothing that could endanger us, just an echo back into the dark. As the arrays prepared to broadcast, the signal from Proxima flickered again. Its timing shifted, its amplitude rose. Then, in one dramatic burst, it transmitted a final pulse stronger than anything before. And then, it disappeared. The silence afterward was immediate and absolute. When the final burst was analyzed, scientists noticed something that froze the room. Its timing pattern matched the predicted delay of Earth's outgoing signal, as if it were answering us ahead of time, predicting our reply before we ever sent it. A response to a message we had not yet spoken. Days passed, then weeks. Every telescope capable of scanning Proxima turned its gaze toward the same point in the sky. Nothing returned. The silence deepened, heavy and deliberate, almost as though the universe had momentarily opened its hand to us, and then closed it just as quickly. Scientists revisited the data again and again, searching for noise, static, cosmic interference, anything that could unravel the mystery. But the math held, the patterns held, the origin held. What didn't hold was the communication itself. The voice from the stars had gone quiet, and the absence left a heavier impression than the signal ever did. If the signal was artificial, then we are not alone. And the nearest intelligent neighbor sits a mere 4 light-years away, close enough to see us, close enough to hear us, close enough, perhaps, to have been listening for much longer than we imagine. But if it wasn't artificial, if it was some strange phenomenon we have yet to understand, then it may hold a different message entirely. A reminder that the universe remains far more complex than our current understanding allows. In either case, the signal forces us to confront something we're rarely honest about. We might not be ready. Not for the truth, not for the implications, not for the responsibility of knowing someone else is out there watching, thinking, wondering about us as we wonder about them. Because every great discovery reshapes humanity. It changes our fears, our ambitions, our place in the cosmos. And some discoveries ask whether we are prepared to change at all. What we know is simple. The signal was real. The data is verified. The origin matches the Proxima system, and the silence that followed remains the most perplexing part of all. Maybe we were contacted. Maybe it was a cosmic coincidence. Maybe something out there reached toward us and is waiting to see what we do next. But one truth remains. The universe is speaking, and sooner or later, we will have to speak back.